Hey, we are group number 3 and we are Eric, Henrik and Vegard. This is our assignment, Boundary Scan. In this presentation, we are going to present the boundary scan block diagrams, an ASMD chart, our Linux design implementation, a test bench, and verification scenarios and the conclusions. This is the overview of all the blocks in the circuit. And this is the boundary scan cells. We have 6 of these in our boundary scan circuit. This is the instruction register cell, and it's a simplified version of the boundary scan cell. We have 4 of these in the instruction register. This diagram shows how the tap controller is connected to the instruction register cells, and how they further are connected to the instruction decoder. This is the bypass cell, and this is a simplified version of the instruction register cell. This is the ASMD chart for the tap controller. Here we have an IR branch and a DR branch. In the IR branch, we can shift in instructions, and in the DR branch, we can shift in bits to the BS cell or boundary scan cell so we can test them. Vegard will now show the VHDL code.
Okay, so this is the boundary scan project in Linux. As you can see on the side here, we have a top level file. This contains all the port mappings for the different blocks in our boundary scan infrastructure. Here we have the different cells. We have the bypass register. We have the instruction register cells. We have the instruction decoder and the port map for the tap controller. We also have some small bits and pieces at the bottom here, like the instruction and the data mux. The tap controller was a really big part of the design work. Here we have all the different states shown in the ASMD chart. And this basically controls how and what should happen in each state. And now Henrik will talk about the test bench.
Yes, and this is the test bench with the various verification scenarios. So here we are in the test bench. In the first, we set the reset to 1 in the test bench, as you can see here. Then we can observe if the inputs match the outputs in the boundary scan cell. And we can see it does. The second was to shift in an X-test instruction, and the boundary scan cells will no longer be transparent. They are now in test mode. Then we can observe if the input matches the output, and it doesn't. The third is to stay in X-test and shift in 6 ones and observe if the 3 outputs of the boundary scan cells are set to 1. And they are. On the fourth, we would shift to bypass, and this is here. And then we would observe if the bypass instruction would return the cells to transparent/normal running mode. And we can see that it does. At the end of the final week, we decided that we would wait with the override instruction until we had finished stage 1 of the task. In the end, we didn't have the time to implement this instruction. Now Eric will talk about conclusions.
This time around, we felt we did a much better job getting started with the project early. We got a lot of the basics about this project done during the first days, so we could start working in Linux and assign the boundary scan infrastructure. We felt this boundary scan project was very challenging. It was a lot of work, but we also learned a lot. We have learned a lot, especially about making different blocks and connecting them through port mapping, and the challenges and difficulties involving this. Overall, we felt we did a good job on this project and that we made a good solution.